Okay, this section is actually 7.3. It's called non-terminating decimals. So the first thing I want to talk about is something we've already seen back in 7.1. And we mentioned it at the very beginning of one of the questions you had from your 7.1 homework. Okay? When did we say that a fraction could be written as a terminating decimal?
When it's only factors of 2.
Okay, the only factors of the denominator. And we've missed one piece.
When it's simplified.
When the fraction was simplified and reduced. Okay? So that was in Theorem 7.1. All right, so Theorem 7.1 said the fraction can be written as a terminating decimal when the reduced or simplified, I'm going to use simplified because that's what you use, Caitlin, that's a good description. When the simplified fraction's denominator had only factors of 2 and or 5. In other words, no other factors besides 2 and 5. That was when that happened. So when can it not? Yeah, so if we have a fraction in the form of an integer over an integer, then the non-terminating means repeating. That's what we're going to be working with today. So you've heard or seen of repeating decimals, correct? So we're going to be working with this idea, and we're going to be taking first the number 1 over 24. So before you work with any fraction, from here till, well, you probably should do it most of the time anyway, but for the way the rest of the semester, you need to first decide if the fraction is in simplified form. Okay? Is 1 over 24 in simplified form? Yes. Why? Because we got 1 on top, right? This is a good one, right? So, but yes, we're looking at whether or not the top and the bottom can factor and reduce any further. This one cannot. So what did we do? And you know how to do this. What did you do when you wanted to change 1 over 24 to a decimal? Divide. So, you're welcome to check things with your calculator, but I expect to see the long division, like the real stuff right now, just like you would expect with your 4th grade students. Okay? So, you're going to show it to me too. So, what's going to go where? 1 goes under. Thank you. 24 is on the outside. And this is actually 1 with a decimal, right? Because this is the number 1. And I've got 24 on the outside. But I need some zeros underneath to just finish this problem. And this is kind of like when you were asking me to create Emily, right? Where I don't actually have a whole number underneath there that I can divide it into. Then I can consider the number 1.00 as the number 100. I can ask myself, how many times will 24 go into 100? 4. So let's make sure we get everything lined up. This decimal point comes straight up here. The number 4 that you just gave me is over the 100, the 0 of the number 100. Last 0, okay? Which means what goes right here? A 0, because base of number 24 did not go evenly into 10, and I consider it as number 10. All right, so what's 4 times 24? 96, and we're going to subtract, and when we do, we're going to get 4. And so I need another 0 that I can then pull down. So how many times will 24 go into 40? Once. 1 times 24 is 24. And I subtract and I get 16. Now what? I need to pull down another 0. Okay, so how many times will 24 go into 6? Or yeah, we'll go into 160. How many? 6. 6. What is 6 times 24? 144. And then, what do I get when I subtract? 16. Now, I actually know right now that I'm done. Why? I got the same piece at this stage that I did before. So what does it mean?
6 recurrence.
It means if I kept going, I would keep getting 6s above the top, right? So the 6 is what's repeating over here. So this decimal is the decimal point 0416. Please be careful. Where does the repeat go? Over the 6 and over nothing else. And if I have to guess where your repeats go when you're losing points, I don't want to have to guess. Just tell me where it's really supposed to go, all right? Really make sure that I understand it's over the 6 and nothing else. Okay, so we call this type of decimal a repeating decimal. And the repeating block of digits is the repeat end. Not quite sure if that's spelled right, but so you. And I've got a note that I already said out loud, so I won't say it again because you've read it. All right, so this idea works really well. And we're going to do another one with the same idea, okay? We've got the number 29 over 99, and we're supposed to write it as a repeating decimal. Okay, so what are we going to do? Divide. What goes where? 99 goes under. 99 goes on the outside. So I think I need to add some decimal, right? Okay, and you're welcome to use your calculator to figure out how many times it goes in. How many times will 99 go into 290? It will go in twice. What is 2 times 99? 198. And if I subtract, what do I get? 92. So I need another 0, right? Okay, how many times will 99 go into 920? How many? It will go in 9 times. What is 9 times 99?
891.
891. You subtract, what do you get? 29. And we're back to where we started. Can you say it louder, Whitney? How do you know? 29 was the same number we started with, isn't it? Okay. So this 29 here and this 29 here match. That's where we started. So we know we're done. If I do this again, I'm going to get what? Another 2. And then I'm going to get another 9. And another 2 and another 9. So what's repeating on this one? The 2 and the 9. So think to yourself what has to repeat on each of these, because it's not always one digit. Sometimes it's more than one. Not always, but sometimes it is. But if we need to know how to change it into a decimal, we also need to be able to change a repeating decimal back into a fraction, which is what we're going to do next. Okay. So we have this decimal that is 6, 1, and the whole 6 and the 1 are repeating. Okay, the bars over the 6 and the 1 combined. And we're going to turn this into a fractional form, a over b, where a and b are integers. Okay, so far so good? The point is turn it back into a fraction. Okay. The process or algorithm by which I'm going to show you to do this looks a little bit weird the first time you do it, so just bear with me and let's work through it, okay? We'll do a second one to further emphasize what's actually happening between the numbers. So here's the first thing you're going to do. The first thing you're going to do is you're going to write down n equals a decimal point 61 with the bar on top. Now many of you probably are, at least some of you, probably remember the shortcut for this particular one on how to change this back into a decimal or to a fraction. But that shortcut will only work in very specific situations. Okay, anybody know what the shortcut is? Awesome. That's even better. Okay, great. All right, so here's what we're going to do. What we really know then is we really know that there are 2 decimals that are repeating, right? So what we're going to do is we're going to multiply by a power of 10 to the 2, because there's 2 decimals that repeat. However many decimals repeat, that's the power of 10 you multiply by. Okay, everybody good? So what are we going to be multiplying by this one? 10 squared, which is 100. Okay, so I'm going to multiply both sides by 100. Okay, so we chose 10 squared because we have 2 decimals repeating. All right, so obviously 100 times n is 100n. So what happens when I multiply the decimal 0.61 repeating times 100? I get 61, but then it still has this repeating part to it, right? So I didn't write it out, but I could have written this out as 61, 61, 61, 61, all the way like that, correct? That's what 61 repeating means. So I'm moving the decimal point 2 to the right because that's multiplying by 100. So I have the 61, but then I still have the 61 repeating part as the repeating part. It's exactly the same repeating part as the one above. All right, okay so far? Okay, you may not be seeing where it's heading, that's okay, but are we clear with those steps? Okay. The next thing we're going to do is we're going to subtract the original value we started with. It looked like n on the left, and it looked like 61 repeating on the right, because n and 61 repeating are the exact same value. We said it. We said n equals 0.61 repeating. So we can subtract like terms to make that work. And that's really friendly, because what happens on the right-hand side when I take 61 and 61 repeating, and I subtract the 61 repeating? I get 61. And that's an integer, isn't it? There's no more repeat, there's no more decimals even. And what do I get on the left-hand side? What do I get? 99n. Careful, it's not division, we're not dividing by n, we're subtracting. So I have 100n minus 1n, that's 99n. My goal is to write this as n equals, so I'll divide by 99. And this would be n equals 61 over 99. And we would check to see if it reduces. 61 and 99 aren't going to reduce, so we are finished with that. Okay? So let me show you a variation of this on the next slide, and then we'll stop there for today. Same directions, what's different about this problem? Only the one repeats. So it is going to look slightly different because of that. Okay? But the process starts out the same. So how did I start the last problem? N equals. Right. N equals the decimal that's repeating just like this, right? And if it helps you to see this written out, write out a little bit further, like I did on the last slide. You can write out that this is 6 with a whole bunch of ones. How many numbers repeat on this problem? 1. So what do I multiply by? 10 to the 1, which is just 10, because there's only one decimal that repeats. We'll multiply both sides by 10. Now on the left again, that just becomes 10n. What happens on the right? I get the 6 first, right? There's going to be a 6 because I've moved my decimal. And it is 6.1 repeating, but that's not especially a helpful way to write it. I want to write it like this. Why would that be helpful? That's it, right? My next step is to do what? Subtract. And when I do my subtraction, what is my goal? I want the repeatings to line up so that they subtract out. So watch what happens when I do that subtraction. I subtract the n on the left, right, that I started with. Okay, not the 10 part here, but. And then I'm subtracting the 0.61 with the one repeating on the right. And I want the repeating bars to line up because I want them to go away. So if I move it so that the repeating bars over the 10th digit, whereas originally over the 100th digit, they're not lined up and I can't do the subtraction the way I want to see it. Are we following? Yeah. So I really need those repeating pieces to match up precisely the same spot in order for them to subtract out. So the subtracting out over here, the ones will subtract out, okay? This piece won't be here. But then I do have to actually do 6.1 minus 0.6, which is what? 5.5, thank you. Right. It's not as friendly as the last one. I mean, I still have a decimal, but I don't have the repeating part anyway, right? So we do a little give and take here. What about the left-hand side? What's on the left? 9n. Then what? Divide by 9. Unlike the last one, I don't get to stop here. What's wrong with this value? I got a decimal inside of a fraction. So Lauren wants to multiply what by 10? In particular, the 5.5, right? That's really what you want to multiply by 10. But if I multiply the 5.5 by 10, I have to multiply the 9 by 10 as well. Okay, so what does that give me? 55 over 90. Do I get to leave it like that? No, what's wrong with that? Need to reduce. What are they both divisible by? For sure and certain they're divisible by 5. What is 55 divided by 5? And 90 divided by 5? 18. And that is reduced. So it's 11 How did you check to make sure that works? Divide in your calculator. If you've done it properly and you take 11 over 18 in your calculator, it should say 0.6 with all the ones after that repeating. Did it work? Excellent. All right, we